afternoon. Today I'm going to show how to use the Casio's fx-570EX Classwiz calculator to numerically solve the wave equations using explicit finite-difference method. First of all, let's consider a string which is positioned over the interval 0 to L. 0 to L. And let's say you have a string here, the string we put from x equal to 0 up to x equal to L. The initial displacement, and this is let's say the displacement of the string is described by the function u(xt), and let's say the initial displacement in time t equal to 0 is given by the function fx. This is the first initial condition. Both strings are fixed such that u0t equal to 0, ult equal to 0. Both strings are high at both ends. So at x equal to 0, there's no displacement. That's why u0t is equal to 0. So this is a left boundary condition. And at the right end, the right boundary condition also x equal to L, so ult equal to 0. And the string is released with an initial velocity. We may pull up, let's say we pull up the string a little bit and we release it with 0, or we may have initial velocity or 0 initial velocity. And let's say, so velocity, if u is a displacement, so the velocity will be your del u del t. So initial velocity means time t equal to 0. That's why you have del u del t x factor 0 equal to kg. X is either with initial velocity or 0 initial velocity. And the displacement of the string uxt at any position x and at any instant t can be described by the wave equations, which is one type of hyperbolic equation. Del 2u del t2 equal to c squared del 2u del x2. Where the c squared is a coefficient, is a coefficient. And then x from 0 to L, t, from time t equal to 0, up to a finite time t. Then by the explicit finite-difference method, the wave equations here, this wave equation at the point xi, the u bracket xi can be simplified using u subscript ij. Then we are going to solve approximate the second derivative respect to time variable and x variable using 3-point central. So that's where central time, central space, finite difference approximation as. We have the point. See here. Horizontal is an x. Let's say center is the x. We do discretize using the I variable. So right point is I plus 1. Left I minus 1. Time t. Discretize using the j. Center is j, bottom is j minus 1, top is a j plus 1. So we have the center point u, I, j. So using 3-point central respect to time t. T is vertical. And recall back how we get the second derivative with y double prime x. It will be f, f x I minus 1 minus 2 f x I plus f x I plus 1 divided by, this is differential respect to x, let's say it's a delta x squared. Let's the increment of the variable x is a h. The increments of the t, delta t is actually the k. And then this one, del 2u, del t2, we differentiate respect to time t is vertical. So follow this one. Exactly, if you want to find second derivative of f double prime x at the point xi, at the point I. So the center point xi here, minus 2 times, and then left point 1 time, right point 1 time, divided by delta x, which is actually the h squared. That's why you have c. The right hand side, del 2 u I, del 2 del x2 u ij, differentiate respect to x. Center point here, minus 2 u ij. You have left point here. This will be u I minus 1 j 1 time. Right point here will be u I plus 1 j. Divided by h squared, where the h is actually delta x. So for del 2 u ij del t2, differentiate respect to t vertical line, center point here, see, minus 2 u ij, and the left is actually at the bottom, which is here, u I. At the line I, so j is bottom level j minus 1. Top is u I j plus 1. So center is minus 2, top 1 time, bottom 1 time. That's why you see u I j minus 1 minus 2 u I j plus u I j plus 1 divided by k squared. K is a delta t equal to c squared. This is a second derivative respect to x. So x horizontal line. So this 3 point. Del 3 del t2 vertical line. Involve this, this 3 point, and exactly make use of second derivative using 3 point centra. Learn in the numerical differentiation. And then we would like to solve to find the displacement of the string at any time t, any position of x. So we want to find uij. So here, if we bring out the k here, the k here, we bring to right hand side. Right hand side. That's why we have kc squared over h squared, which is written as a rho squared. So we have kc squared over h squared is a rho squared. So in the rho is actually kc over h. We want to solve uij plus 1. Also got 3 level. Compared to the heat 2 level, so 3 level. So solve for the point uij plus 1. Solve this one. So the other 2 terms, you can bring to right hand side. So these 2 you bring to here. So you have a minus uij minus 1 here. And this term, you collect it here. So you have actually 2 uij minus 2 rho squared uij. So now you see involve all these 1, 2, 3, 4, 5 point. 5 point formula, but involve 3 level. With 1 time of uij plus 1, if you look at this molecule here, 1 time of uij plus 1 equal to your left center level, which is rho squared. Left center left bottom level, and this one exactly center middle level, which is 2 minus 2 rho squared, and here ui plus 1j, which is rho squared. Here rho squared, this is minus 2 uij, minus 2 rho squared uij, collect with this term, so 2 minus 2 rho squared uij. This is plus rho squared. From here uij minus 1 is the level j minus 1. From equation 5.8, we can draw it to molecule graph. So 1 time of uij plus 1, then from the equation form we change to the graphical point. First it will be easy to memorize the graph rather than the equation. So we have 1 time of uij plus 1 equal to rho squared of ui minus 1j plus 2 minus 2 rho squared uij plus rho squared of ui plus 1j minus uij minus 1. So we have three levels. However, the top level that we are going to solve still one cell. That's why this is still explicit formula. Explicit formula, but involve three levels. Involve three levels. So if the bottom level or the level minus 2 here is an initial condition, then you still need this level. You still need the information of level minus 1 so that you can solve. If let's say this is level 0, the level 1, then you can solve for your level 2. So mean this is from initial condition. If this level from initial condition. So you need level 1, so that you can solve level 2 upwards. So now how to get the level 1? To get level 1, remember we got the second initial condition, which is the initial velocity del u del t, when t equal to 0, del t at any position x at time t equal to 0, is given by function gxi. If initial velocity is 0, then gxi here equal to 0, then it will be easy, ui1 will be equal to ui minus 1. We have a general, let's say initial velocity is gxi. So initial velocity, let's say we just consider three level. I get here delta t is this is using 3-point centra for first derivative. 3-point centra for first derivative, we got f prime x is actually your fxi plus 1 minus fxi minus 1 divided by 2. But this is del u del t, that's why delta t is k, that's why divided by 2k. How you get ui1 minus ui minus 1? Say we got here t equal to 0. Say t equal to 0. Let's say j here is 0. J is 0, and then del u del t at t equal to 0. We use 3-point centra. So this is j equal to minus 1. This is j equal to 1. And then this one is I at this point, u, I, 1. So using 3-point centra, because we differentiate u as respect to t. So 3-point centra, differentiate respect to t. So your forward point, because it differentiate respect to t. So this is ti plus 1 minus ti minus 1. Will be your ui 1 plus 4. Sorry, ui, this is 0. Level 0, ui 1. So the bottom here is ui minus 1. That's why you have ui, comma 1 minus ui minus 1 divided by 2k equal to gxi. So we solve for the point, we want to solve this one. The level j minus 1. So that's why ui minus 1 is equal to, when you bring 2k up, so ui minus 1 will be ui1 minus 2k gxi. Right, this one. So you got 2k, and then when you have ui1 minus ui minus 1 is 2k gxi. So this one will be ui1 minus 2k gxi. And then you substitute this one to the 3-level scheme 9.8 with j equal to 0. Now the 9.8 here. I copy it down. This is of 9.8. Okay, because this is general uij plus 1. Okay, now we at the specific when t equal to 0, j is equal to 0. Okay, j equal to 0. That's why we will have substitute j equal to 0. We will have here ui1 equal to rho squared ui minus 1, j is 0, plus 2 minus 2 rho squared ui 0 plus rho squared ui plus 1, 0 minus ui minus 1. Because at t equal to 0. So ui1, okay, plug in j equal to 0. So ui1 equal to rho squared ui minus 1, j 0. So plus 2 minus 2 rho squared ui 0 plus rho squared ui plus 1, 0 minus ui minus 1. Okay, and then you plug in this thing. Plug in this one into here. So we get ui minus 1 replaced by, so minus ui1 minus 2k gxi. Okay, and then solve for your ui1. Okay, solve for ui1. So this term and this term you collect together, you have 2 times. Because minus ui1. In these two yellow color term you collect together 2 times. So you want 1 time, so this one divide by 2. This one divide by 2, divide by 2. So negative, positive divide by 2. That's why you get K.G.Tay. So equation 9.10 is to use to solve for level 1 only. It's used to solve for level 1. We want to see the molecule. So mean one cell of ui1 mean for level 1 only, okay, is equal to rho squared over 2 ui minus 1, 0, depend on level 0, plus 1 minus rho squared ui 0, plus rho squared over 2 ui plus 1, 0. Okay, this is actually plus. K is a delta t, gxi is a initial velocity. So means once the level 1 is solved, okay. So this is for initial condition, level 1 solved using the initial velocity. Okay, using this is initial condition, this is initial velocity. Then you can solve level 2 onward using this 3 level scheme. So the 2 level scheme is only for level 1, because it's obtained using the initial velocity. Okay, with this, let's look at one example. Given the wave equations, del 2u del t2 equal to 4 del 2u del x2. Okay. So the 4 is actually from here, c squared equal to 4, so c equal to 2. So x from 0 to 1 is positive, the boundary condition u0t equal to u1t equal to 0. Okay, t solve from 0 up to 0.02, and the initial condition is given ux0 equal to x times 1 minus x, initial velocity del u del t, okay, del t ux0 equal to sin 2 pi x. Okay, for x from 0 to 1, using the explicit finite difference method, solve the wave equation by taking h is actually delta x equal to 0.25 and k is actually delta t equal to 0.01. First, we draw the grids. Okay, I draw the grids in the table form. So I have x from 0 up to 1, increment 0.25. So 0, 0.25, 0.5, 2.5, 0.75, 1. Okay. And then t from 0, increment is 0.01 here, 0.02. So decrease. Okay, and then fill in the initial condition ux0 equal to x times 1 minus x. Okay, I will quickly get this value using table mode rather than you calculate one by one. Okay, let me show you. If you use calculate mode, then you input the initial condition is alpha x 1 minus alpha x. Okay, this is using calculate mode. You calculate one by one. Usually x 0. You got x 1.25. And calculate again. X now 0.5. We get 0.25. Okay, calculate again. Now x is 0.75. Okay, 0.1x75. We make equal so. Okay, now x is 1. Then you can press equal, press K, calculate 0. So if you use calculate mode, input this function, then you need to input one. Okay, x for 0. 0.25, 0.5, 0.75, 1.55. This is using calculate mode. Okay, since the increment is consistent, which is h 0.25, and you have starting, ending value, okay, I will recommend that you use table mode. Number 9. Good. Okay, the function is x 1 minus alpha x. Equal. Okay. In this model, you can input two functions. So you don't have the second function, you put it to 0. Okay. Starting 0. Ending is 1. Stack is 0.25. So one shot. You don't need to calculate one by one and input the x value 5 times. Straight away you can get the whole initial condition value out. Okay, if you want to off this gx, you need to shift for that. Equal. You choose you want 1 only. So now it's only 1. Okay, if you want to plot the graph, shift options. Okay, you use a handphone to scan the QR code, and the graph will be shown in your handphone. So this is the initial condition. Initial displacement. And then we fill in the boundary condition. Left boundary, right boundary are 0. So we got 6 value to find. How I label this is U11. Because x we label using the I variable. I start from 0, 1, 2, 3, 4. Okay, T we use a J. J start from 0, 1, 2. So we call it this one U, I, J. So this is I is 1, J is 1. So U11, U21, U31, up U32. Okay, I2, J2, U22, I1, J2, U12. That's how we label it. Okay, after we put it, draw the grid with initial condition, boundary condition, and we know, okay, we got this 6 value that we are going to solve. Okay, now we calculate the molecule graph or level 2 onward. Okay, H delta X is 0.25. K is a delta T, which is 0.01. C is 2. Calculate the rho. Rho is actually KC divided by H. So you get 0.0. K is 0.01. C is 2. H 0.25. So you get this rho, and then the rho square is 0.0064. Okay, and we calculate 2 minus 2 rho squared. 1. We calculate the rho. Left on 0.1 times 2. It go down 0.25. So 0.0x squared it. Okay. So the rho squared. Okay, this is rho squared. This is rho squared. Okay, this cell is 2 minus 2 rho squared. We call back how we get it. Okay. Using 3-point central for time, 3-point central for space. Uij plus 1. Okay, at the middle level, left cell, row square. Okay, center cell at center level. 2 minus 2 row square. This is row square. Okay, the right cell. This is the level J minus 1 in this molecule. We calculate row square. 2 minus 2 row square. This is minus 1. So your 2 minus 2 row square is here. 2 minus 2 by answer. 0.9872. So this is a molecule. Okay, be careful. This molecule used to calculate level 2 onward. Level 0 initial condition. So you need to calculate level 1. Okay, to calculate level 1, you need the initial velocity. Okay, initial velocity given is what? Sin 2 pi x. Sin 2 pi x. So we have, okay, the theory that we derived just now. We got this molecule. Okay, if you notice, this molecule is actually from 3-level molecule. This one, divide half. This, okay, to eliminate this one using the initial velocity, then we get here to solve for level 1. Okay, one time of ui1. It depends on row square over 2. Okay, left bottom cell, center bottom is 1 minus row square. This row square over 2 plus k, which is delta t, times the initial velocity. And the initial velocity. So if we draw that 2 levels k molecule. So this is 1 minus row square. Actually from here, we divide by half. So you get 0.0032. Okay, this here the right cell, okay, also 0.0032. Okay, and this value 4.9872 divided by 2. Okay, 0.9936. 0.9936 plus k 0.01 times the initial velocity sin 2 pi x. Sin 2 pi x. And then we use these 2-level scheme to calculate level 1 only. Level 1 only. Okay, for example, you want to calculate, this cell is actually what we call U11. Okay, this cell is U11. Okay, U11. Here, what's that? Inside. Okay, this cell U11. Okay, U11. U11. Okay. Follow the molecule. U11 depend on 0.0032 U00. U00. Okay, left. Okay, this is the left bottom, center bottom, right bottom, plus 0.01 sin 2 pi x1. Okay, I here. This is I 0, 1, 2. Okay, so U 1, 1. Okay, will be equal to how many times? The coefficient for left bottom cell is 0.0032, which is row squared over 2. Okay, left bottom cell. This cell is U00. Okay, this cell is U10. Okay, this cell is U20. Plus 0.01 sin 2 pi. Okay, you add here. This is x0, x1. Okay, and you calculate, you may put it this way, and then if you calculate manual, then you are going to calculate 0.0032, and then you need to key in this cell value, which is 0, and you write this way, and then you plus 0.9936. U10, the value is 0.1875. Okay, plus 0.0032. Okay, U20, the value is 0.25. Okay, plus 0.01 sin 2 pi. Okay, x value, okay, when you calculate U11, the x is 0.25. It's 0.1971. Okay, I'm going to show you. It means to calculate here, you have to write this one, and then maybe you also need to, after you write this one, before you get this result, you may need to write also what is U00, which is 0, U10, which is 0.1875, U20, which is 0.25. Okay, x1 is 0.25. Means you write this formula with one step, write in the value for U00, U10, U20, x1. Second step. Third step, key in the operation including the value of U00, U10, U20, x1. Third step, then you get the result here. So this is only for U11. How about U21, U31, U3, U31, and later on U12, U22, U32 using 3 level scheme. So is tedious and troublesome. Okay. So here, you notice, if you want to calculate U21, is actually, I variable, one will change to 2. Okay. So U21 depend on here, which is U11 and U10, U20, U30. Only the value here means if U21 if we have U21, it's the same operation, only the value change. U21 here depend on, this cell is U10, 0 plus 2.5986 0 plus 0 plus 0.01 See here, you want one? Okay, this is your left bottom, the center bottom is right bottom. If you now target to here, so your left bottom is here, this is U10, center bottom is U20, right bottom U30, and the x is at 2.5. Okay, this one you write, if you last time you copied manual, you write this one, later on you need to write again. 10, this value 0.1875 plus 0.9936 U3 U20, the value here 0.25 plus 0.0032 U30, this is 3, 1, 2, 3, 4, 0.1875 plus 0.01 sin 2 pi. Okay, x2 value is 0.5. And then press this thing in your calculator. Okay, or you may, your calculator you may change. This one now become, instead of 0.25, it become 0.5. You may edit. You change here. Okay, from 0.25 now change to 0.1875. Okay, or last time if you don't have MS on Word, mean you need to repress again. 0.1875 now change to 0.25. 0 go to 0.1875. So you get 0.2496. So you see here purposely show you if without using formula, you need to write here, write the value for U10, U20, U30, x2, okay, and you need to press the calculator, okay, or you may edit back the first formula that you key in, but still troublesome, you may wrongly edit it. So what I'm going to do is, okay, the left bottom cell here, I represent using A. Center bottom is B, right bottom is C. Okay, the value of X, of course I use X. So I'm going to use this formula. In 0.0032 alpha A. Left bottom has A, A plus the coefficient for center bottom is 99336 represent using B plus 0.0032. Right bottom is C, okay, plus 0.01 sin, make sure in radian mode, 2 pi alpha x. 232C, 0.996, 0.9936, 0.9936, 936B, 0.00328. Okay, you calculate. So, okay, when you want to calculate, you want the here, this one, A is left bottom, B is center bottom, C is the right bottom. So A is 0. Okay, B is 0.1875. C 0.21. Sorry, X not 1. A 0, B 0.1875, C 0.25. Okay, you calculate here the X, the same position, 0.25. Go down, X is 0.25. So you get 0.1971. Okay, 0.1971. So to calculate U21, okay, A will be here, this will be B, this will be C. So calculate again, just change ABC. Just need to change ABC. So A is 0.1875. B 0.25. C 0.1875. Okay, sorry. I need to change the X of 0.25 move to 0.5. Okay. A here, B 0.25. A is 0.1875. I'm going to calculate here. To calculate U21, A is 0.1875, go up 5. And then B is 0.25. C 0.1875, correct. Okay, my X, U21 X, the same position, which is 0.5. 0.2496. 0.2496. Same with what just now. Instead of you key in this formula, you key in this line, I represent this is okay, this one, this as A, this as a B, this as a C. Okay, X of course is the X, so I just need to change ABC value. See, the A is A, this value is B, this value is C. Okay, my X 0.5. So now, if I want to get here, Now I get this value. So A is the left bottom, A, B center bottom, C is the right hip bottom. We will calculate A. So okay, A now from here, point 1 example, you notice ABC value will move, okay, one cell to the right. So from point 1 example, move key into point 25. AB change to here, 0.1871. C now is 0. Okay. X. We want to calculate, okay, Q, this is Q, this is 0, 1, 2, 3, U31, U31, the X is 0.75. From 0.5 move to 0.75. 2.1771. So now we get level 1. So we can use a 3-molecule cell molecule graph to calculate U12. It will depend on these 3 values, 4 values. U11, U12 depend on this cell, and this. Okay, U12, remember just now our 3-level molecule. We're using the shortcut. So U12, you want to apply this molecule here. So I'm going to key in this formula. This is A, this is B, this is C, this is D. The formula 0.0064 A plus 1.9872 alpha B plus 0.0064 alpha C minus alpha in U12. Now J is this is 0, 1, 2. 0, 1, 2. U12 depend on 0.0064 time of the left bottom, center bottom, right bottom, and in the level 8 minus 1 bit. So I already input the formula. This one is without using if you're not using calculator, mean U12 is 0.064. Okay, this is U01. Okay, plus 1.9872 U11. Okay, plus 0.0064 U21 minus U10. So the cell U01, U11, U21 is at the left, center, right, at the immediate level, and then U10 is at the bottom hip level, the center bottom level, minus 2. So I input in the calculator and calculate. Okay, when asked value, this is A, this is B, this is C, this is D. Okay, this is an A value, this is a B, this is C, this is D. If A is 0, if B is 0.1971, if C is 0.2496, if D is 0.1875, then you get 0.2058. 2058. Similarly, this one, if you're not using the formula, then you need to press 0.0645 U01 is what? 0. Plus 1.9872 U11 is what value? 0.1971. Okay, plus 0.064 U21 is what value? 0.2496 minus U10, which is minus 2.1875. And then when you move to here, it's only A, B, C, D value move. Okay, means when you induce to 2, okay, when you induce to 2, okay, you focus here. So this is left, this will become A, this will become B, this will become C, this will become D. Okay. This down, this down, this down. So A, B, C, D. So calculate again. A now is 0.1971. B 0.2496. C 0.11771. D is 0.25. Which is 0.2484. 2484. Okay, you want to how you get this one? A here, B here, C here, D here. So calculate again to get the U32. The A is 0.2496. The B 0.1771. C 0. D 0.1875. 0.1660. So with this, you no need to write down tedious. Write that this way. Then write what's the value for U01, U11, U21, U10. Then key in the calculator. Then for U2, U22, U22. Right, okay, similar thing. Okay, so I repeat over time. Okay, we have shown how to use your scientific calculator. Okay, scientific calculator. But here, how to use a scientific calculator to numerically solve the heat equation in calculate menu. Okay, where the first you draw the grids. Okay, you draw the grids, and then you draw the grids. After that, okay, fill in the initial condition, boundary condition, level 1. Okay, you use a level 1 molecule. Molecule here. It's a level 1 molecule. Solve level 1. Okay, after you obtain the level 1, this is a initial condition in level 1, you can get level 2. Okay, this example, okay, we got 5 columns. 5 columns that I can show you in the spreadsheet menu. Okay, however, in spreadsheet, I will reverse. I can show from bottom to top. I will show from top to down. Spreadsheet. Should be now 8. Okay. Okay. In spreadsheet, okay, reverse. This one is top. Okay. And okay, we have only 5 columns. So if your solution need more than 5 columns, you cannot use spreadsheets. So first thing, okay, level okay, and the spreadsheet, this is start from 1, this is 2, this is 3. First, fill in the initial condition, x by 1 minus x. Okay, so I key in into this cell first. So alpha equal, okay, x. So I need the x. So I will key in because I need the x, so x I will key in at level 1, I mean the row 1 is row 2, row 3, row 4 in the spreadsheet. So I key in the x value first, 0, 0, and then 1, 2, 5, you need to equal, you go down and up. 0, 2, cell B is 0.25, C1, 0.5, 1.75, E1 is 1. So I fill in the X, okay, the X at row 1 in the spreadsheet. So my row 2 is the initial conditions. Start from here. So in the spreadsheet, okay, this is A, B, C, D, E. So this cell is actually column A, row number 2. So now, okay, I want to fill in here in the cell A2. I want to key in the X times 1 minus X when my X is stored in A1. So I have A1 times 1 minus A1. Okay. Alpha equal, okay, X is stored in cell A1, so alpha A1 vector 1 minus alpha A1. Then I'm going to copy the formula options. Go down to copy, then move to left, right to equal the place, we get the 1.1875 here, equal, replace it, equal, replace it, okay, from here, place it in the AC. So we get the initial conditions at row number 2. Row number 2, initial condition. Okay, and fill in the boundary. 0, 1, 0. For value at the boundary. ABCD 0, 0, 1. Then I got 6 value, right? 2, 3. BCD value of 3, 4 exactly, okay, at t equal to 0.01, t equal to 0.02. Okay, solve it. And then okay, I will plug in the U11 in formula into 112 into your spreadsheet. So what's the formula that I need to plug? It is reverse, because spreadsheet is from top to down. So the formula is in the molecule. And you need to reverse it. Okay, this cell depends on left top, center top, right top, and depends on the current position of your X. Okay, where the left I'm pin formula in B3, where B3 is equal 0.0032, okay, and B3, then my left, okay, because it's reversing in spreadsheet, so the left is at A2, then this is in A2, this will be in B2, this will be in C2, okay, the X will be in X, X is stored in actually X is B number 1. Also in column B, X is the first row, 1. If we add column B, left is A, right is C, okay, X is stored in B1, okay, and then now we in row 3 depend on row 2, so A2, B2, C2. So my formula is equal to 0.0032 alpha A2 plus 0.9936 alpha B2 plus 0.0032 alpha C2 plus 0.01, okay, and then sin 2 shift 5 and x is in alpha b1. We get 0.1971. 0.1971. And repeat the formula. Because in the spreadsheet, give it from top to bottom. So we are keying into the cell B3. It depends on the previous level, which is at level 2. Okay, row 2. Here we are in column B. Left is A, so A2. This is center bottom is a B2. Okay, right bottom is C2. The X score in B1. Okay, once it's done, we copy the formula options. Then go down to 2. This. Go to this. This one is a boundary condition, so AC. So check it, the level 1 value. In spreadsheet, from display from top to down. What's that? Oh, complete level 1. 0.1771, okay, 0.2496, 0.1971. Okay, we have the level 2 already, and level 1. Now we need the level 2 where we key it in the cell B3. Cell B3. Cell B3. So in the cell B3 now, this one, in column B. So okay, spreadsheet is reversed. So this column A, column B, column C. Okay, A, B, C. So in B4. Okay, B4 depend on the immediate level, which is B3. So this will be A3, B3, C3. Okay, this is immediately B2. We key the formula alpha equal 0.0064. Because here depend on A3. So alpha A3 plus 1.9872, alpha B3 plus 0.0064 alpha C3 minus alpha B2. Because here B3 depends on the immediate bottom level, which is okay, because I'm in B4, okay, so this will be A3, B3, C3, this is B2. So, see, check the value. $2057, and you can copy, okay, right, paste, this is boundary, so AC, check, 0.1660, 0.2484. Okay, if you don't want to show the formula, you want to show the value, shift to for spreadsheet, okay, you do show cell, show value. 0.2058, this value 2484, 1660. Okay, basically, I key in the level 1 formula in the spreadsheet. Okay, spreadsheet key in into B3, yeah? Okay, I'm standing here, column B. This is 3, B3. Okay, now the spreadsheet, okay, this one is on top, so this will be level 2. Okay. Standing at the B3, left will be A, so A2, B2, C2. Okay, that's why my formula, show back the formula, okay, number 4, show cell, show formula. Let's see, A2, B2, see the formula, okay, you need to edit cell. Shift, so this is options. That only you need to see the formula because too long. On 0032, I key in here 0.03282 plus 0.9936B2 plus 0.0032C2 plus 0.01 sin 2pi times x. Okay, x is stored in column B, B1 because x is actually, okay, the x is actually the first row. X is the first row. Second row is the initial condition. So third row, okay, third row is the first level. Okay, column A is the boundary condition. So that's why, okay, I key in this one in the cell B3. B1 initial condition. That's why this is a B1. So my formula, okay, in the cell B3 is 0.003282 plus 0.9936B2 plus 0.0323 C2 plus 0.01 sin 2pi times B1. Sin 2pi times B1. Okay, I get here and then I options. Okay, you go down number 2, copy and move to right to paste. Okay, paste 2 times because we got total. I copy, key in formula here, I copy and then paste 2 times. Okay, later on to calculate U12, U22, okay, U32, we need the 3-level scheme. In the cell here, I'm standing at the B number 4. This is cell B4. Okay, left will be A, center is B, right is C. Okay, B4 because spreadsheet is from top to down. So the bottom level, okay, is actually the previous level, which is at row 3. So this is A3, B3, C3. This is at the same column, so B2. So my formula is 0.0064 A3 plus 1.9872 B3 plus 0.0064 C3 minus B2. Okay, then I get this value, I copy and paste 2 more times to get complete level 2. Complete level 2. So if you have level 3, same thing, you can copy here, paste. So you can click. As long as you have level 2 onward, you can use copy the formula from U12 to paste it up. In manual it's up, but in a spreadsheet it's paste down. Okay. Still have one. I option, I copy, move down, I paste it, paste it. See, this is a boundary 0. This is boundary 0. Okay, however, the spreadsheet here has limitation of 5 columns only. If you have more than 5 columns, then you still need to use back the calculate menu. Then we put up the left bottom is for level 1. Left bottom is A, center bottom is B, right bottom is C. Okay, and the X is X is the same column, okay, with the current cell that you are going to target the same position, in the same position with the targeted cell that you are going to complete. Okay, once you complete the level 1, you use a 3-level molecule to get your level 2 onward. So where this one, okay, the cell I put as A, this is B, this is C, this is D. Okay, it is. Thank you for your attention.